Welcome back to another episode of Climate Tech Spotlight. Today's a really interesting episode, not one that we've done before, which is going to focus on data centers, AI, and a company's really innovative technology that is moving the needle on a variety of aspects. We'll dive into that, but for now, Ben, welcome to the podcast.
Thanks for having me, Lewis.
It's great to have you here. You've got a really interesting background, and I think it's worthwhile just setting the 30,000 foot overview as to why you're here and how you became to be a part of the data center space, and obviously working for a company that is moving the needle on AI applications within data centers. So why don't you give us a background as to how it all started for you?
Sure, yeah. So without going too deep into the background, I had kind of a meandering career. I was originally, my undergraduate degree is in manufacturing engineering, so I do have kind of an engineering foundation. But I went from undergraduate directly into sales and marketing. So I was a commission-only sales manager of a regional kitchen cutlery company for a little while. Did that for about 10 years and then decided to go back and get my MBA. And I went to a very unique program up in the state of Vermont here in the States, the University of Vermont. Program is called the Sustainable Innovation MBA. And it was really about kind of building the next generation of business leaders who are really incorporating not just shareholder returns into business plans, but stakeholder returns as well, right? So kind of how can businesses really take into consideration the 3 Ps, people, planet, and profit. Went to that program. Then after that was working on a consulting project for PepsiCo for a little while down in Guatemala. Ended up then getting a position with a sales and marketing firm in Vermont. We were a HubSpot partner, so learning kind of the SaaS sales ins and outs and customer success side of those things as well. And then I got an opportunity to interview with the large firm Ingersoll Rand. Ended up being hired by Ingersoll Rand in October 2018. I moved to where I live now in Charlotte, North Carolina in 2018. And I was hired there as the sustainability programs leader. Ingersoll Rand at the time was a conglomerate that owned multiple brands like Trane, the HVAC company, yep. Thermo King, transport refrigeration, right, and Club Car. And then about 2 years into my time there, Ingersoll Rand went through kind of a divestment process and split and sold the Ingersoll Rand brand to another firm that became Ingersoll Rand. And then what was remaining, which was Thermo King and Trane, became Trane Technologies. So I was a sustainability programs leader there. I reported directly to the VP of sustainability. We were an enterprise team, and our goal as about a 6-person team that we had was to assist the organization in all sustainability initiatives, whether those be internal or external. So, for example, those of you that are familiar with Trane Technologies, or if you're not, take a look. They have a Gigaton Challenge program where they've committed to reducing their customers' emissions footprint by 1 billion metric tons by the year 2030. So that was a goal that was announced in late 2019. So it began in 2020. So I was part of the team to help kind of put that together and get that going. And then I also worked with a lot of the sales and marketing people within Trane Commercial, Trane Residential, and Thermo King on what they could and couldn't say about sustainability programs. So making sure they weren't greenwashing or kind of over-promising what we could and couldn't do. But basically helping the organization also developing educational programs for employees, making sure people understood the language of sustainability. And during my time there, sorry, I have a little alarm that comes on.
No, you're good.
I like to listen to some jazz while I'm doing my work in the morning. During my time there, I was introduced to a woman named Katie Hoffman, who was our innovations leader. And Katie was involved with a project that Trane was working on with Google at the time. So DeepMind was involved. And this was kind of the early days of applying machine learning and artificial intelligence to industrial control systems. So Google and Trane were working together at a couple different sites to apply what Jim Gao at the time at Google had done internally there. They were trying to, figure out, could they commercialize this service? Could they, utilize it at large chiller plant systems? And so Katie came to me, told me about what she was doing, and asked if I could help kind of compute the or get an estimate for what kind of emissions reductions capability this project could have. And so I found out about it then and kind of kept in touch with Katie. And then when Katie was deciding to leave Train, this was late 2019, early 2020. She had let me know that when they were when she was leaving, to found a company called Phaidra with two other individuals who were leaving Google. She told me that I'd like to keep in touch with you, and when we're ready to scale, we'll make sure that we have an opportunity for you to come in. Sorry, I've got dogs here.
All good.
So anyway, I was interviewing. She came back to me, in February of 2022, and let me know that they were about to close their Series A and that they were ready to kind of scale a sales program. And so I interviewed with them, and then in May of 2022, I came to my role now, which is business development lead at Phaidra.
Nice. That's I mean, it's an interesting background, to be honest. Given the fact that you saw the challenges and tribulations with Ingersoll Rand and Train. Again, they've separated now, to the best of my knowledge.
Yes. Yeah.
So with Phaidra then, let's talk a little bit about the solution. So what does it do?
That's a great question. So at the high level, Phaidra is a supervisory level AI control system. So we are not replacing on-site BMSs or for the data center industry, DSIMs or SCADA systems. It is simply a supervisory layer of software that kind of sits on top. We're cloud-based, so we're not on-prem currently. So our services are technically off-prem. Our system will take in live telemetry data. So our first major application that we are scaling in the market right now is on mission critical cooling. So we focus only on industries where cooling is an absolute critical aspect of the business. So data centers being our primary focus, you can imagine data centers create a lot of heat as the IT load is ramped up throughout different data halls. And the removal of that heat is critical to their business. So these are HVAC systems that are running to some degree 24/7, 365. Now, granted, some data centers are located in cooler climates, so maybe they're not running as much as that, but most data centers have some level of mechanical cooling running pretty typically, at least at some point in time, every day of the week. So we also have customers in the pharmaceutical and district energy industries as well. But again, we're talking about cooling where it has a specific business purpose. So for our pharma customers, obviously keeping medicines and vaccines in production at precise temperatures is very important. And then for district energy companies, obviously their product primarily, besides heat, is chilled water, right? So making sure that chilled water remains in production and remains at a very specific temperature to meet their customer SLA goals. So, but data centers are our primary. So if you think about any kind of industrial system, particularly one within a data center, you have a control system that is essentially monitoring all the equipment throughout the facility. And you have an operations team that is responding or reacting to different things that occur within that system. And whether that means they're changing set points at the control system or they are changing things at the equipment level, they are sporadically throughout the day responding to different events. The control systems typically do have some programmed logic in them. They are usually commissioned and programmed to follow a particular, what we would call, or what's an SOO, so it's sequence of operations. So they do have a kind of level of programming to essentially maintain relatively conservative control of the facility. The challenge with those is that they're static, meaning that they are commissioned and programmed and then they remain that way for several years. Of course, operators do make manual changes and updates. They get to know the facility. They get to know, how things work, and they might lean on certain equipment over others. So they do make manual changes as time goes on. But throughout the entire industrial community, all controls as they exist today are relatively static. So again, things are commissioned. The program or the controls are programmed. And then as equipment is used throughout the day and throughout the years, equipment degrades. So the efficiencies and things like that change. The effectiveness of the equipment changes. But the controls remain static and the sequence of operations remains static unless, and companies do this, but every couple of years they might pay another couple $1 million to have another controls vendor come in, reprogram them, update those systems, and gain some efficiency. But then as time goes on, the same kind of process occurs, right? So they they're statically programmed. They work for a little while, their efficiency trails off, and then they might do it again to get that efficiency back, and so forth. Phaidra, what we do kind of in parallel with that is we leverage AI and machine learning as a way to create dynamic control systems. So our service, is taking in this live telemetry data. So think about sensors all throughout the facility related to the cooling system. So whether it's a chilled water pump, whether it's the chiller itself, whether there's cooling towers on the roof, whatever it may be, we're taking in live telemetry data. So this is in some cases, a few thousand to maybe tens of thousands of data points, right? And it's taking this information in about every 1 to 5 minutes. We like a minute, 5 minutes is okay. But obviously, the more fresh and live the data is, the better decision that the AI can make. So it's taking in that information. Our machine learning system is then computing based on what's happening in the facility and what's happening with the outside environment, right? So including weather data. The system is then determining what the best combination of set points is to first and foremost meet the stability, right? There has to be a level of stability in the system where the temperature is remaining constant or is at least remaining below what a maximum kind of hot out temperature would be. So the first and foremost focus of the system is to maintain that stability and never risk our customer SLAs, right? So the service level agreements they have with their own customers. But the system also then is achieving that objective with a secondary function of achieving that objective with as little energy as possible. So it's actually trying to make small tweaks and changes to the system throughout the day to make sure that it's meeting that stability demand, but also doing it with as little energy consumption as possible. So it's essentially, a moment by moment optimization focus. So it is a dynamic system that can respond typically a little faster than human operators do to outside weather changes or interior changes with the environment inside. And it's essentially making the right decision at the right moment, at the right time, every time, and kind of reconfiguring set points here and there. It's not making dramatic changes in a lot of ways. It's just making small tweaks and changes and responding dynamically to, for our data center customers, the IT load shifts and therefore the heat profile shifts that happen throughout the day. And that's happening on a continuous loop. So it's a closed loop system. So it takes that data in, makes the decision, sends the set point commands right back down to the local control system for implementation, and then it repeats. So it's doing that 24/7, 365 to maintain that stability and to use as little energy as possible to achieve that number one objective, which is stability.
Okay, got it. Really interesting. What about, the solution reminds me a lot of what you typically see, and I'm sure you saw this at Train, but the like building analytics or FDD, where it's either focusing on predictive or preventative maintenance. Is that tied into the solution as well at Phaidra?
Another good question. So what we are building ultimately is an AI platform, right? So one of the first things we have to do with our customers is actually get clean and enriched data. There's a lot of technical debt in the industry. And that's at no individual fault, right? It's just the way things are in a lot of cases. Systems get commissioned, systems get up and running. And then over time, either sensors are not calibrated or sensors maybe stop functioning, and you're going to have some gaps in the data. So one of the first things we have to do to get up and running with a customer is actually go through and clean their data, make sure that there isn't any gaps, or make sure that there isn't anything that stands out as an incorrect sensor reading. So we do have a process where we actually go through and kind of clean that data, and then of course the enriching part is making sure that we have an understanding of the relationship between different pieces of equipment. So trying to think with your question here, the way I would best describe it, our AI and machine learning systems are not taught a model of each piece of equipment. So we're not taking the Train piece of equipment or Carrier piece of equipment or whoever is the manufacturer of the equipment. We're not taking that piece of equipment and using its power efficiency curve as an example and teaching an AI system, hey, this Train chiller has this power efficiency curve and you can rely on it to always have that, because that's all theoretical. That's how that piece of equipment should work from day one, right? As time goes on, by the time you get to day 1000, that chiller is not meeting that exact same power efficiency curve as it was on day one. So we need the historical data, or really the clean data from the system, to actually train the AI models on. So we're not teaching it the power efficiency curve of a particular chiller. It is learning the unique power efficiency curve of a unique chiller based on the data related to that chiller's use. So it's inferring that curve from the information it's receiving from that particular set of sensors. The reason I'm saying that is that we are not building like just a theoretical model or a theoretical example of the system that a customer has. We're essentially teaching the AI and the machine learning tool that we're using
Yep.
off of the actual historical and live data for that customer. So it has a very realistic understanding of the reality within that system every single day. So it understands the relationships between the pumps and the chillers and the cooling towers. It's not being taught what those relationships should be theoretically. It understands what those relationships are in reality from the data that it's used. So
Right. Okay.
in terms of like the difference, we're, as far as we know, we're also the only closed loop autonomous service, meaning that our system actually doesn't just provide analytics or information on maintenance or things like that. We are actually sending the right commands back to the local system, and that way it can actually be implemented right away. So we are not a service in which an operator is going to be having to watch a dashboard and like make a bunch of changes that the system is showing it. Any set point recommendations coming from our system are passed to the local control system. Now, of course, the local control system always acts as the kind of end-all safety mechanism. Our system, if it ever sends any control set point that would be outside of the typical bounds that programmed logic control system has, it would just ignore it. Our system doesn't do that, but as a safety mechanism, the actual PLC control, the actual BMS system on site of the customer acts as that kind of end-all be-all safety mechanism to make sure that no set point commands are kind of outside of the normal control set point commands. So what I mean by that is when we are sending that information, and I'm not the connectivity guy, so I'll tell you this, it's actually more of their system is requesting it, right? And we're then responding to that request to bring that information back down to them. We're not relying on simply a human operator to review that and then implement, because that would just be a lot of time and effort from one or multiple individuals. Our system can write that autonomously. So that's one significant difference. I would say the other difference here, we don't necessarily have where we're at currently. We don't have like a preventative maintenance alert system within our current platform. But going back to what I mentioned a moment ago, what we've done with our current customers is we have this AI platform. We have clean and enriched data coming into it. And then our application right now is autonomous control of the mission critical cooling system. We will layer in other optimization platforms as well, preventative maintenance being one of those things. Now, our system won't tell an operator like, hey, this chiller or this pump or this filter needs to be cleaned, or it's looking like this is coming up. We will build those functionalities into it as we scale. But our system can at least identify that there's been a change in the data related to a particular subset of the system or a particular piece of equipment. So it still is, in a way, monitoring something that maybe should be looked at by a human operator. We just don't have a specific preventative maintenance application in there yet. But it will recognize if something has changed in a way that it didn't expect, right? Maybe there's a clog or something in the filter. All of a sudden, it sees that a sensor reading has changed in a way that is too much of a significant change to ignore. So it can notify users of that as well. We just don't have that formal like preventative maintenance layer. But all that's to say is that's coming, right? That's all part of what we are building.
Yeah, that makes sense because it blends in nicely with already the smart technology that you've got in your wheelhouse at Phaidra. Going back just quickly on data, and you spoke a lot about getting clean and enriched data. I'm sure you can remember during your train days, and probably same at Phaidra, but one of the biggest challenges with connecting OT and IT and the convergence of both is data silos. How are you combating that with the AI technology that you've got?
Yeah, that's a good question because as an example, a lot of organizations, they have a BMS, right? Building management software, building management system that contains the telemetry data. But then they might have something like a CMMS, which is their maintenance tag information, right? And that's what They can create tickets from that when maintenance needs to happen. And in a lot of cases, those two systems are siloed, right? And it's up to a human operator, manual individual to go and make these changes within one. So as an example, when we are implementing our service at a particular location, right? We're establishing a read-only connection with the BMS so that we can bring in that telemetry data. When we look at that telemetry data, let's just say, there was a period of time where Chiller 3, within the last 6 months, looked like it was not functioning or not available. Well, within the BMS system, if there's no tag between the CMMS and the BMS, or the CMMS has the information, Chiller 3 was out for maintenance between date A and date B. If there's no connection between the CMMS and the BMS, so that the BMS understands that Chiller 3 was unavailable for the reason that it was out for maintenance between these dates, if it doesn't have that context, then we would call that unenriched, right? Or that would be an example of an unenriched piece of data. Versus if we can tag from the CMMS over to the BMS and we can bring in the fact that at this point in time in the historical data set we're looking at, Chiller 3 was unavailable because it was out for maintenance or because it was being maintained, that adds some contextual relevance that the AI is going to consider, right? Because without that contextual relevance, the AI might just think, okay, Chiller 3 during that period of time isn't available normally. When the reality is it just wasn't available because of a particular maintenance event. So that's an example of enriching. Another good example of enriching is the variability in data. So a lot of data center co-location companies, so these are the companies we tend to work with right now, they run their systems in a very conservative way. So if this is the maximum temperature that they are able to keep, either their hot aisle out or their chilled water system, whatever it is, if they have a maximum temperature that they've agreed to with their customers that they will never go above, they usually will run their systems at some comfortable level lower than that. But the real opportunity to save energy and therefore reduce emissions, reduce energy consumption, is to get that temperature as close to that maximum as possible and kind of ride that line as time goes on. So in order to get some more enriching data, like if we can get involved in a commissioning process for a new facility, that's where we can get some really good enriched data. Because during commissioning, that's where they will ramp things up and down. They'll go to IT load near 100%, then IT load near 20%, and so forth. And so variability in data and the changes, even dramatic changes, ramping up to 100% in a 24-hour period and then down to 20% within 24 hours later, and so forth, and kind of going back and forth up that roller coaster. In that maybe couple of weeks or a month, whatever, if a system is doing that, is variable pretty frequently, the data in that 1 month to us is more valuable than a year of data of conservative control. So what we mean by that is when you have that variability of data, you're seeing a lot of different interactions between the pieces of equipment. How the pumps respond, how the chillers respond, how the cooling towers respond, how all the different elements that are within that cooling system. If you have some variability, then you're seeing a lot more examples of the relational impact between them, right? Not everything is a linear curve, right? Like for example, we know fan walls and the power consumption of fan motors. It is not linear, right? As a fan ramps up, you're getting kind of more of a oh gosh, I'm forgetting my mathematic terms here, but you're not getting a linear power curve, right? As it's spinning faster, you're actually consuming less energy per rotation, right? So, these kind of relational elements between all the different pieces of equipment, if there's variability in how they've been run over any period of time, that's a more enriched data set than just conservative, consistent control over a long period of time. So that's what we mean by enriching. So again, we typically go through a soft life period once the system is connected and set up, where we are simply soaking in the data, and our system might be providing recommendations, but they're not actually being implemented, at the right command level yet. So we do spend a little bit of time in a soft life period also, so our system is kind of learning and understanding the relationship between these pieces of equipment. I think
so. And in terms of from the initial implementation to actually like the the AI, Phaedra's AI, is ready to go and it's achieving what it's supposed to be doing. I appreciate that there's a evolution period and there's changes to that, but typically, what is the cycle?
Are you saying what does it take for the implementation to get up and running?
Yeah, I can ask it in a different way, but what I wanted to talk about is just very quickly is like from once the AI is implemented within the data center,
Mhm.
when do you start seeing the positive changes that you've
Oh
ultimately
yeah, I
sold
got
to
you.
the customer?
So the two important distinctions here. One, typically we will notice some energy efficiency savings immediately. It's pretty minimal, but what happens is the AI is not coming in and learning from scratch, right? It has some understanding of the system from the historical data and from our soft life period of soaking in that data. So right away, it starts to make some decisions that save a little bit of energy. And I think the important thing to understand here is that the majority of the energy savings we're able to provide our customers isn't coming from some crazy new strategy that the AI thinks of or understands or determines that humans are not understanding or determining. It's really just coming from saving small amounts of kilowatt hours, consistently throughout the day, every day. And it
Got it.
does that by simply just making a decision that the human operator probably would have made. It just maybe makes it a little bit earlier. It sees something, it understands something, it understands the relational dynamics, and it just makes a small change that shaves off, a couple kilowatt hours. But it's doing that all day, every day, and over the course of a year, you're talking about megawatt hours, right? So when it's first turned on, you'll start to see some energy efficiencies in the single digits within the first few weeks, right? It's kind of making these small adjustments and changes right away. Now, all that does depend on how conservative the operations team there was running that facility, right? If they were running it super conservatively early on, we might see a little more energy efficiency. If they were already trying to initiate more energy efficiency plans, we may see a
Yep.
little less energy efficiency gain, right? It really depends on that. But I will tell you, the first distinction here is that the most important thing to our customers is stability. Energy efficiency is something that they aspire to, and it is a goal that they have. But you can't ever have energy efficiency at the sacrifice of stability of their systems, right? Because that is the number one primary thing. So what we've done with a lot of our customers, because we know that operations leaders they need to be able to trust the AI. They need to be able to understand and trust the system and feel that it is making good decisions that are safe and optimal for their facility. So we over constrain the AI in a lot of ways. So at the very beginning, I'm just going to use my hands here because it's the best
Yep.
possible definition.
Here we
Let's say
go.
this is how wide the rules of their system are, right? The temperature bounds, the set point changes that can be made. Like they have agreements with their customers that they're never going to go outside of these bounds. So instead of from day one, our AI is not usually operating with the same constraint bounds that system realistically has. We will over constrain it so that the AI has less movement, less capabilities initially. And we do that for anywhere from 30 to 90 days so that the operations team there feels comfortable and understands that the AI is playing by all the rules, it's maintaining stability, and it's obeying essentially the commands it's been given to work within. Then as time goes on and they feel more comfortable, they feel trusting of it, we can expand those constraints to match more of the reality of their customer SLA constraints that they have in place. So again, does it make some magic huge impact on day one? Not necessarily. It depends on some of our customers were a little more comfortable with constraints being loosened. Some really wanted extra constraints put on it so that they could build some trust and understand the system a little bit better. So it really varies. The second distinction, though, is that the type of AI and machine learning we leverage is called reinforcement learning. This is a type of artificial intelligence. So it's a subset of the broad category of AI and machine learning in which our system learns from the actions it takes in the environment based on the impact that those actions are making. So when it makes a slight tweak or change, and then of course that tweak or change happens in reality in the system, and then it sees the next round of telemetry data. A minute later, it's getting new fresh telemetry data, or 5 minutes later, right? It's getting that new fresh telemetry data. The AI is basically understanding: did that change I make move me in the direction towards my goal or away from my
Yep.
goal? Am I rewarded for that decision, or am I penalized for that decision? And it's doing this constantly on thousands of different data points throughout the system. So it's just doing, really effective math very, very fast and doing it, lots of cycles throughout the day. So it makes these set of changes or tweaks, and then it looks at the telemetry data immediately after following those new action sets. Did it move me towards where I need to go? Am I more stable? Am I more efficient? Yes, great. Okay. Then I learned that combination of things at that moment under those particular circumstances was a good decision. Am I less stable? Am I less efficient? Okay, well then I learned that those changes in those contexts did not get me where in the direction I wanted to go. So it's I think about like the sailors of old on a ship, right? They're never heading in exactly a straight line. Like airplanes today, people think that airplanes fly, they don't fly directly straight lines. They are
No.
constantly making these slight changes and navigation changes because wind and pressure, and if you're talking about sailor, like the water, the waves, like there's so many different things that are moving that system. And the captain's job, right, is to simply make sure that they are navigating towards that ideal future point. Same idea with this system, right? It's always looking to navigate towards that objective, which is stability with energy efficiency being met. So
Nice.
again, that's what's
Very
happening with reinforcement learning. So over the course of a year, the longer our system is engaged, the better it becomes. And also
mhm.
the more effective it is at handling dynamic change. For data center customers right now, they are dealing with a lot of, I mean, this industry is booming, right? So they're dealing with a lot of changes in a more rapid way than they ever have before. You've got, companies like Nvidia that are producing chips that consume quite a bit more energy than the chips that they have currently on their, and you're getting racks now. Racks in a data center historically have been 5, 10, maybe up to 20 kilowatts. Now you got racks that are coming in 40, 50, 60, even 100 kilowatts in a rack.
It's
That's a
crazy.
very different heat profile, and that's a very different problem for operations leaders to solve. The AI is simply a tool that helps them respond better and more effectively and more quickly and more dynamically to a lot of these changing things that are happening within their data halls. And again, the
Got it.
more that it's up and running, the longer period of time it is, the better it becomes at understanding that unique system. So really, you know, every virtual plant operator, we call it, that we're deploying at a particular site, uh, as it's up and running over time, it becomes that much better at running that unique facility because it understands the actual realistic relationships between the pieces of equipment. It is not just trying to make decisions based off of a theoretical model. It knows how that equipment works based on the telemetry data and
Yeah.
how things are
Yeah.
changing and happening in that facility. Yeah.
Yeah, I was going to say that. Okay, that's really really good to know. Good analogy as well, by the way. I don't think we've ever had a sailing analogy on the podcast yet. So stability, like you said, is key. It sounds like it's one of, if not the most important goal within data centers. But um, and we spoke about this in our planning call, but there's so much energy being used by LLMs or Gen AI, depending on how you want to describe it.
Yeah.
There's been reports by big tech companies that are struggling to meet their energy goals due to this large scale AI use. Um, how is your AI supporting them in terms of energy efficiency, and also how does that set it apart from more intensive AI systems like LLMs?
It's a great question. So, Phaedra's mission at our core is to provide radical resource efficiency. That is our ultimate goal, right? As we scale and as we build AI powered, control systems, we're focusing on the industrial sector, one, because it makes good business sense, right? You know, Small points of efficiency in the industrial sector can mean big dollars in savings, or even big top line revenue because you have more product coming out or you have more stable product coming out, right? Obviously, our long-term goal is to become a ubiquitous kind of control system that simply is a supervisory layer on top of all industrial controls, right? To optimize and solve for any of the particular challenges within any flavor of industry, right? Um, with data centers in particular, and the challenge of AI and the boom in compute demand right now, um, it has really shifted the landscape in terms of just a year ago, right? A lot of the hyperscalers, big tech companies, Google, Microsoft, you had these companies talking about becoming carbon neutral, or I think even Microsoft, right, was like, we're going to remove all the carbon we've put in the atmosphere since whatever 1970s when they were founded, right?
Mm.
And then all of a sudden now you've got this kind of um, you know uh, uh, arms race to secure more land, more power, and build newer and bigger and more dense data centers than ever before. So now you have this energy spike that obviously leads to an emissions spike because unfortunately no grid on the planet right now is 100% carbon free. Every grid has some carbon in it, and some have more and some have less, right? So you have this massive spike in energy demand that is really challenging them on all of these goals they set. And here we are, 3 months from the midpoint of this decade, and a lot of these companies have goals that they want to meet by the end of this decade. But now you have this kind of shift in the environment, or the shift in this challenge that they have, where their energy demand has skyrocketed.
Hmm.
So, you know, when you think about AI, the challenge with that term right now is it is very broad, and and for in a lot of ways it's a talking point, right? There are a lot of people are talking about how they use AI, or they might be slapping, making some algorithms and then calling it artificial intelligence, which
Mm.
I don't want to get into that, or kind of the specifics of that. We have better and smarter people in our organization who can walk people through the differences really in the different types of artificial intelligence. But my point here is that the compute power related to artificial intelligence is correlated directly to the data set that is being needed to use as the input for the AI to have an output. So, to back that up, when you are interacting with a product like ChatGPT or any of the LLMs, or like any of the LLMs, or the video based ones, right? So when you are providing a prompt and you're either getting an output that is text, or an output that is an image, or an output that is a video, when you are interacting with them through the prompt that you're providing, the amount of calculations that system is having to do is hard for the human brain to fathom.
Mm.
You are talking about, in a lot of cases, trillions of instantaneous mathematical calculations occurring, primarily because the data set for these LLMs, or these video, AI systems, the data sets are massive. I mean, you're talking about with ChatGPT, you're talking about every written word on the internet almost. I mean, you're talking trillions and trillions of data points that this system is trying as fast as it possibly can to comb through, calculate, and output a result that is meaningful and based on the unique prompt you gave it. And the amount of compute related to that is hard to imagine. It's significantly more than something like a Google search without the AI, right? Like, all of us searching from our phones or at home, laptops, whatever.
Yeah, you don't
The
really think about that, do you?
I don't think many people do, but I think most people are probably you know I think more people are becoming aware of their own energy footprint. Maybe not their emissions footprint, because that's kind of ethereal, and emissions are usually produced away, from an individual's home. But I think more and more people are aware of maybe how much electricity they may be consuming throughout the day. But when you're searching through something, and this compute is happening in a data center that may be, a couple hundred miles away from your home, that's harder to actually think through, right? And it feels like a Google search. It feels like the same thing. You're just typing in information and it's outputting something to you pretty very quickly, right? Almost instantaneously, it's coming up with something. But the amount of calculations that have to be done in order for it to produce something that's relevant and meaningful to you is many orders of magnitude more than something like a Google search. So all that all that's to say is that the relative data set that an AI is leveraging to do the computational math to get the output that you're wanting it to provide you, or you're hoping it provides you, the data set here directly correlates to the compute energy. So when you have something like Phaidra and what we're doing, Our system is looking at the data set of the telemetry data of the cooling system within that facility. So comparing us to like an LLM, for example, an LLM is looking at billions, hundreds of billions, trillions of data points. So that compute can be very, very large. Our system is looking at a couple thousand, tens of thousands, maybe, depending
Okay.
on how large or how complex the system is. So our compute power is orders of magnitude less than an LLM. And an LLM is putting out text, which maybe some people are using that for better productivity at work. Maybe some people are just using that for emails they're sending to friends and family. Maybe people are using that, just for fun, just to kind of goof around and see what kind of outputs they get. Our compute is taking telemetry data, so significantly smaller data set, and coming up with an output that is then helping the customers at their end actually reduce the energy consumption. So the
Nice.
ratio between our compute and the consumption reduction we're providing to customers is a pretty significant ratio. We're actually in the process of having conversations with our cloud provider, so that we can actually come out and say at least a defensible amount, how many orders of magnitude from our compute power, because obviously our systems are they're consuming electricity, right? They have to run some compute. But because our data set is so much more manageable, and the AI system can turn that manageable data set into meaningful actions, right? That do, save our customers energy. We want to understand that relationship even better, because I personally think as business development lead, that's a really great story to share. And so we're
100%.
yeah, working on getting that kind of that math worked out so that we can share it, and we can share a number that is probably pretty substantial, but also defensible and meaningful.
Okay.
Yeah.
When we were speaking before we started recording, you were talking about the concept return on energy.
Yeah.
Is this what you're talking about, or is this slightly different?
No, that's exactly what I'm talking about, right? So we are, hopefully by early next year, after I've kind of had these conversations with our cloud provider, um, you know, the return on energy here is I would love to understand, for every kilowatt hour that our cloud compute is consuming, how many kilowatt hours are we able to save our customer? And that ratio between what we're consuming and what we're helping save, to me, that can be very meaningful. And because our data sets are much more manageable, or the customer's data set that we're operating off of is so much smaller than something like, an LLM or like a video processing AI. I think the return on energy, for our type of application of AI, will be something that will help everybody understand where AI can be used to effectively optimize, um, what right now are the kind of energy hogs of
Hmm.
the entire global economy, right? Which is industry. Um, and so I think that's where we can help people understand there are many different ways to use AI. Some might be some might be considered more wasteful in terms of the return that is maybe not occurring, versus kind of a niche focused application like we have, where the return can be very significant, and that 1 kilowatt hour on our end can save a substantial amount of kilowatt hours on the other end. So that's what we're talking about with return on energy, because um, you know modern infrastructure, albeit being very, kind of good and polished, a lot of our modern infrastructure is pretty inefficient. It just is, right? We
That's fair.
lose a lot of heat energy. Not obviously not every electron that's produced is actually going to make it, all the way and be consumed on site. Even when it gets to on site, there's still losses. And we're running stuff very conservatively. We're kind of building a lot of redundancy, into our infrastructure. Um, and so, we err on the side of stability, and what kind of goes out the window in a lot of cases is efficiency. But I think as we kind of enter this fourth industrial revolution with, things like IoT and everything being censored and having data related to it, AI can really help us become hyper efficient, and reduce and remove all of those wastes without sacrificing the stability. Which also,
No.
one thing I'm really excited about over the next decade, right, is when we as we grow and scale, and we prove that, you know what, operations teams, people don't need to be thinking about doing these mathematic calculations all day, every day. No one wants to do this mundane, repetitive, and complex work all day, every day. It would just be exhausting. And it would be very hard to keep up, right? So if we can push the mundane, repetitive, and complex mathematical work to AI and machine learning, freeing up the humans to do more of the on-site maintenance, to do more of the long-term strategic planning and thinking, right? The level two thinking that we're really good at, that humans are very attuned to. Push all that level one, heavy, dense mathematical calculation into the machine world. That's where I think a lot of exciting opportunities open up, not just with kind of labor in the workforce and new training and new ways of having people kind of engage with these systems. But I think also as we prove that you can have complex industrial systems run hyper efficiently and hyper effectively, then you might have this shift in how things are designed and built in the future. And you're thinking, right now we build a lot of redundancy into our industrial systems out of an overwhelming sense for a need of either control or just safety or stability in it. But if we can prove that these AI systems can maintain that stability with less equipment, right, being deployed, now you're talking about significant changes in the way things that are designed and built. So, data centers in the future or industrial facilities in the future may have more compute and more capability with less equipment. And that's a really exciting thing, I think, for the sustainability world in general, right? Because that's a huge shift in the scope 3 side of things, the supply chain side of things, right? Where, future industrial facilities are ordering 30% less materials and equipment because they don't need that anymore, because an AI control system can run everything stably with less equipment. So I think that's a really interesting, kind of topic and thought process too, as we grow and scale, and maybe there will be others, right, that come along with us. But as we start to show that kind of mundane, complex, and repetitive work can be very easily managed in an AI machine learning system, it will start to change how things are designed and built. I would say within the next 8 to 10 years, it will shift, and I think that means a lot, upstream in the supply chain, right, and how things are purchased and procured, and that means a lot of materials even at the far end of the upstream, right? The materials inputs will shift and change, and so that little 2 millimeter change at the controls end will make a dramatic change in the upstream procurement and processing of raw materials for equipment. So anyway, that's another kind of exciting thing that I think will be a ripple effect of stable and hyper efficient AI and machine learning control systems.
Yeah, I was going to touch on this because when you think about data centers, you mentioned it there. Like, it is as an industry, it's an energy hub, but with a very large opportunity. Probably not right now, but do you think data centers in the future will ever be set up where the concept of having a decarbonized portfolio is a reality?
I think that yeah, I mean, yeah, the short answer is yes. And I think that because of their significant energy demands, they have a particular opportunity to work with utilities, right, on new investments in renewable or storage, right? And obviously, data centers today all have backup power systems on site, right? Because they, any moment of downtime is a significant business cost to them, right? So they can't just rely on the grid being 100% reliable all the time. They have, backup power systems on site. They have storage systems on site so that they can run islanded, right? And they do this. They test their systems typically, monthly or even more frequently than that to make sure. So they're always able to kind of switch into, an islanded mode and continue running. I do think though that they have an opportunity to partner with utilities to encourage more carbon-free types of renewable energy sources. I do think also, data centers as they evolve and continue to demand more energy, I do think that there is, and also, there are communities that try to resist data center construction, right? Because they are large facilities that don't tend to have as many salaried jobs related to them already that other facilities or other commercial entities that have the same kind of land or power expectations take up, right? So there is a lot of resistance already in communities about building new data centers. So I think, and I've talked to data center operations leaders about this, and so it's already something that's being discussed. And I'm sure that there's already conversations happening. I do think that the data center of the future will not only be a place where compute for your internet access and or things like self-driving cars will happen, but I do think that they also will become utilities in their own right, and will have probably energy production on site that hopefully will be somewhat decarbonized, if not completely decarbonized, and will be able to provide, some level of energy back to the local grid. And so I do think that there's a shift probably occurring in the data center industry where they are not just going to be the receivers of electricity from the grid, but producers as well. And I think that that's an interesting conversation that I don't know a ton about, but I do know that the conversation is happening, and that's one thing that data centers are thinking about. I also know from my experience at Train, it was a great case study with a data center provider over in the Netherlands. I think it was in Rotterdam. It was just outside of Amsterdam.
Yep.
But there is a data center company that is acting as a district heating provider for some
Okay.
surrounding community elements, right? So this is called North Sea Data Center. There's a great, easy to read case study on it that Train Technologies has on their website. But data centers produce a lot of heat. Well, instead of just removing that heat and sending it to the atmosphere, what if that heat was captured, put back into some medium, and then given to local facilities that were somewhere around it? So this example in the Netherlands, this data center is producing heat, obviously, as it runs. That heat is then transferred to water. That water is then pumped to like a gymnasium. It's pumped to, I think, a greenhouse system. It might even go to a school. There were multiple kind of, community facilities that were all hydraulically linked together. And they're, of course, using that heat to, in the wintertime and in the colder times of the day to for comfort heating, right? Or for production heat for, I think it was for like a greenhouse, right? So not like crazy industrial production heat, but just useful agricultural heat. And then, of course, they're returning cold water to the data center. So the data center is taking that cold water in to use again. So it's a continuous loop. And also, I know for a fact that those pumps that were pumping that water were all powered by solar. So you had this almost net zero community energy system where the data center is both producing heat that's useful to the community and receiving chilled water from the community as they take heat from that water. So great example of a private public partnership. And I think data centers will have a very outsized role in providing kind of district utility benefits as they scale. And I think Europe's, a couple steps ahead. The U.S. Is going to get there as well, and it will trickle to other economies. And so I think that's a really exciting way to think about what a data center could be, as opposed to just a taker of energy. It can be an integral part of a utility system for a community. And I think that that's a really exciting conversation that is happening as well.
Yeah, I like that approach. Just before we move on to the next stage, you've obviously spoken a lot about cooling and optimization. But when you think about Phaidra's AI and some of the needs of data centers, is there any other applications like water conservation or power generation where the AI is making an impact?
Yeah. At the highest level, I can tell you that if there is enough sensor coverage and there are some toggles and switches or actions that can be taken to make changes within a system, then you can apply AI to optimize it. Bottom line, there is no limit to that. As long as there's enough sensor coverage and there is the ability to make changes in the system from a central control standpoint, then you can apply AI to optimize it. If you think about what we're doing at a high level, we are simply using the same theory that two of our co-founders, so Jim Gao and Veda Paneershavam, they both came from Google DeepMind. And one of the things that Veda was doing before Jim actually met him was he was part of the AlphaGo engineering team. And to your listeners, if you haven't heard of AlphaGo, I highly suggest go to YouTube, search AlphaGo.
There's a free 90-minute documentary on there. It's fantastic, and it will help you understand AI and machine learning and its applications probably better than I can. But the point I'm trying to make here is that AI for AlphaGo, simply what they did, and I'm going to say simply, but obviously it was super complex. But at the simplest level, it's game theory. You're teaching an AI the rules of a game, the pieces in that game, and what those pieces can and can't do, and then you're giving it an objective. And in our case, we are doing the exact same thing, but for mission critical cooling. And to answer your question, Lewis, we can do that exact same thing for other things in the future, right? Like water optimization, like power optimization. Probably as we expand into the chemical or O&G industries, we're probably going to talk about batch processing, right? Where instead of continuous flow processing like we're doing now, which is chilled water and moving heat outside of a system, there's also batch processes, right? So chemical companies are putting together large amounts of chemicals for a single batch and then trying to get obviously their product on the other end of the output. Any industrial process can be automated to an extent and then optimized using AI. And it all goes back to this game theory, right? What are the rules of the system? What are the rules for each of the pieces that are in that system? What can things do? What can't things do? What are the constraints? And then ultimately, what's the objective? Or what is the set of objectives? And maybe more than one, right? Like for us right now, number one objective is stability with the side objective of as efficiently as possible. So it all comes back to game theory. So what we're doing is, the AI is not a creative thinking, machine. It is not coming up with, like it's not human intelligence, right? It isn't capable of inventing a new system. It is, but it is supremely capable at becoming excellent at running a specific system. But it still has to understand and be taught what that system is, what the boundaries are, what the rules are, and what the objective is. So we can take that exact theory and apply it to any industrial process. The reason we are doing mission critical cooling now is because that's where we are the deepest in our expertise right now. Our team, we have about 104 employees currently, and we have three types of experts in our organization. We have artificial intelligence and machine learning experts, right? So people who are deep in this industry, like Phaidra and the engineering team that we have behind him. We have people who are fantastic at software, right? They've built software for major companies. They understand it ins and outs, and they're exceptionally good at it. And then we have people who understand controls and mission critical cooling. We have people from Train, from JCI, from Carrier who understand these systems and know, they've designed them themselves. They've managed them themselves. So those three expertises combine to make our system super effective. Exactly. So that's why we're building and scaling there. But as you can imagine, as we become larger and as we become more effective, we will hire the experts we need for other applications and combine our machine learning and software experts with those experts to provide the best solution for that organization. Because I think there's some AI companies out there that build software, but they lack the internal expertise. So they're relying on their customer to teach them what they need. We've taken a different approach where we have the internal experts. So when we work with our customers, we're not relying on them to teach us what they need. Our experts know and understand their systems already, but we still do have to communicate with their on-site experts and their technicians, because our experts need to understand some of the tribal knowledge and the nuances, right? But our people talk their language, right? They're not having to learn something and then develop something for that. We have an application that's ready to go for that particular use case. But yeah, to go back to your original question, we will provide more applications than that as time goes on. We can layer in other ones, like obviously with some of our data center customers that are in water stressed areas. We're already in the process of talking to them about water optimization. But if you think about our platform, that's just another layer. That's another objective for the AI to seek, right? Because now what you're doing is you're saying, okay, your job, AI, is to maintain stability, to do it with as little energy as possible. Oh, and by the way, here's another layer of sensor and control systems. You also need to use as little water as possible. Now you have three objectives. So now you're playing the game to win those three things all simultaneously. So yeah, I'll leave it at that.
Yeah, I was just going to say, I mean, it sounds like it's been an incredible journey thus far, and you're only
It's
really
fun.
getting
I'll tell you what, I know,
you're only really getting started.
we've got brilliant people in our organization, and I think it's it's a true pleasure to work with them. I certainly feel humbled by the conversations that I'm having with the people that I work with internally, and to boot, we're fully remote, so we're operating on at least 3 continents right now. And we have customer deployments in North America, Europe, and the UK, and right now in APAC. So we have deployments in Singapore and probably coming online in Japan and Australia here pretty soon. So, and that means that we have people spread out too. Right? I'm East Coast US. We have a few other East Coast USers, but about a third of our company is in North America, a third of the company in the UK and Europe, and another third in India and the Asia Pacific region. So, I don't get to see them a lot in person, but I will tell you the conversations we have are fascinating, and we just have some incredibly brilliant people that are at this cutting edge of actually leveraging AI to, like I said, create hyper efficiencies rather than something that's kind of a fun or slight productivity increase tool.
Yeah, and this leads me on to my next question as we look to wrap up. It seems like it's just the start from a technology standpoint. There's so many other applications that may come into play over the next few years as the team grows and as you understand, as you continue to understand how your AI works, but also how some of the trends in data centers are going to shift and potentially how you need to put that back into the service of the product. As a business, you've raised 60 million to date. Series A, probably looking at Series B in the next 18 months, maybe sooner. High level, because I appreciate you probably don't want to share too much, but what does the future look like for Phaidra over the next 12 months?
So over the next 12 months, we have kind of 2 primary goals, right? And you're right. So I think our total raise Series A now is about 62.5 million, and that might include seed as well. We have some fantastic investors, right? The public ones I can mention, and you can look at press releases for us, but like Mustafa Suleiman, one of our investors, Mark Cuban also, which is really kind of fun. These are seed early on. Our most recent Series A extension was run by Index Ventures, which they're massive. Flying Fish Partners, one of our originals. So I'm a little disconnected from that side of the business, but all that's available on our website, so you can take a look there. In the next 12 months, our focus is, twofold. We are not, as a business, we are not necessarily looking at trying to acquire hundreds or thousands of customers, right? Our focus is becoming ubiquitous within the data center kind of control space. So, we have a couple of large co-location companies now, and we are rolling out expansion plans with them. So that's number one focus, is expanding to multiple, many locations within some of our key customer accounts. The other secondary focus is continuing to onboard, new customers in that way. I mean, we are in contact with, I don't know what I can and can't say, but we're in contact with, a lot of the right people. So we have a lot of the right eyes on us. And of course, we're talking about a mission critical process. So there's no room for error. And that's why when we're onboarding and working with a new site or a new customer, we're building the tools to make this more efficient and faster, but we take our time, right, in making sure that the data is clean and that it's enriched enough to drive value for our customers as well. So the next 12 months is really about expansion, the right, we do turn down customers, just to be frank, like we are looking for the right partners that are open to this kind of experience and also are willing to discuss expansion, after at least 1 or 2 sites are shown to be, our product is shown to be effective there. But I think the other thing that we're doing is building out the internal tools and processes for us that make more of what our people do for each site that we're deployed at a little bit more automated and effective, right? So just like any startup, trying to make sure that we are as efficient as possible with our own people's time. I do know also we are in the process right now of developing, you could call it another product. So it's something that is it relates to everything we've discussed that we do already, but it would be probably something that more of our customers would want sooner rather than later. And I'm not going to talk about it much in detail now. It will be
What a
launched.
tease.
Yeah, it will be launched by Q1. It's I'll tell you this, it's not the same. It's not autonomous control. That's what we are providing now.
Mm-hmm.
But for us, it's going to be another way for customers to find and receive value from our type of AI platform before we ever get to autonomous control with them. Because getting to that autonomous control point takes we're still taking a significant effort, right? And we're very clear with our customers about this. This is not a plug and play software. This is not, something that you can buy with a credit card and set up an account and you're going, from day one. This is something that takes some effort. There is controls vendors involved, their operations team is involved. I mean, this is a multi-person effort to get up and running from day one, as it should be. This is a critical system that needs to have the utmost care and concern when you're talking about making changes to it, right? So the new product that we are coming out with, that our head of product is in the process of developing, is more of a way for us to get them some value from their own data and information before we get to the autonomous control part of that facility. So anyway, that's all I can say about it for right now. I got a kind of a sneak peek look at it this week, which is really cool. And I believe we will have it. I think some of our current customers will start to have access to it before the end of this year. And then we'll start talking about it probably publicly in Q1 of next year.
Nice. Well, we'll have to get you and maybe one of the co-founders back for another episode on season 3. But Ben, it's been great to have you on. I'll put Ben's contact details, LinkedIn, for example, in the show notes, as well as the company website. But Ben, thanks for joining me. It's been a really interesting episode, and I've learned a ton, so appreciate that.
No, thanks for having me, Lewis. I mean, it's a fun topic to talk about, and obviously it's pretty timely. Everybody's got AI on the mind, and you hear a bit, people are sometimes just throwing it into their discussions because it's something that everyone feels like they need to be talking about now. But no, it was really, really good to have this discussion, and I hope that your audience has learned something. I hope there's a nugget there that you can take and move forward with.
I'm sure they have. We didn't even get time to talk about crossing the chasm, but next time.